Have you ever wondered, what was there before everything? We're starting our cosmic journey at the very beginning, the Big Bang. In the grand cosmic scheme of things, our universe's story begins with a bang, not a whisper. But this wasn't just any bang. This was the Big Bang, the explosive moment of creation that marked the dawn of time and space. Picture, if you will, an infinitely small, infinitely hot, infinitely dense point known as a singularity. This singularity contained all that ever was and all that ever will be, crammed into a space so small that it defies comprehension. Then, in less than a blink of an eye, this singularity began to expand. It wasn't an explosion in the traditional sense, but rather a rapid stretching out of space itself. This expansion happened faster than the speed of light, filling the void with a hot, dense soup of particles. Within seconds, the universe grew from a microscopic dot to a sprawling cosmos, and it's been growing ever since. The Big Bang Theory, as we call it, is the prevailing cosmological model for the observable universe. It's the most widely accepted explanation among scientists for how our universe came into existence. It's built on decades of observation, calculation, and yes, a little bit of speculation. But don't be fooled by the name. The Big Bang wasn't actually an explosion, and it wasn't big, at least not to start with. It's a metaphor for the rapid expansion of space from a state of extremely high density and temperature. So why do we believe in the Big Bang? Well, there's quite a bit of evidence to support it. The universe is still expanding today, just like it did in its earliest moments. We can see this when we look at distant galaxies and observe that they're moving away from us. And then there's the cosmic microwave background radiation, the afterglow of the Big Bang, still detectable today, almost 14 billion years later. So, from a hot, dense point and a massive explosion, our universe was born. The universe wasn't always a cosmic wonderland of galaxies. So how did these galaxies form? Well, to understand the origins of galaxies, we must journey back to the early universe, a time of chaos and darkness, when the universe was just a baby, barely 100,000 years old. At this time, it was a hot, dense soup of particles, primarily hydrogen and helium, with tiny fluctuations in density. These minute density variations were critical. They acted as seeds, creating pockets of matter slightly denser than their surroundings. As the universe expanded and cooled, these pockets became the cradle for the first structures to form. Enter dark matter. This mysterious substance doesn't interact with light or normal matter, but it does have gravity. Dark matter began to clump together under its own gravitational attraction, creating halos. These halos of dark matter acted like cosmic scaffolding, attracting normal matter into their gravitational embrace. Inside these dark matter halos, the normal matter, primarily hydrogen and helium, began to pool together. As more and more matter fell into these halos, the force of gravity increased, pulling even more matter in. This process, known as gravitational collapse, led to regions dense enough to trigger the birth of stars. These early stars were like cosmic light bulbs, illuminating the universe for the first time. As more stars formed, they began to cluster together, creating the first galaxies. These early galaxies were the building blocks of the universe. They merged and grew, forming the diverse range of galaxies we see today, from spiraling disks to elliptical giants. The formation of galaxies is a testament to the power of gravity and dark matter, forces that transformed the universe from a homogeneous soup of particles into a cosmic zoo of galaxies. And so, from the dust and gas of the early universe, galaxies started to take shape. In the heart of these galaxies, something spectacular was happening. Stars were being born. Imagine a vast swirling cloud of dust and gas, a nebula suspended in the infinite cosmic expanse. Over millions of years, these nebulae, the nurseries of the universe, collapse under their own gravity. As they shrink, the material at their core grows denser and hotter, forming a protostar. This protostar, a glowing orb of gas, isn't a star just yet. For that transformation to happen, it needs to get hot enough to ignite nuclear fusion. This process, the same one that powers the sun, involves hydrogen atoms combining to form helium, releasing a tremendous amount of energy in the process. When this fusion begins, a star is born, shining brightly against the dark canvas of space. These stars, depending on their size, can live for billions of years. Smaller stars like our sun burn their hydrogen fuel slowly, living long, steady lives. Larger stars, however, live fast and die young. They burn through their fuel at a rapid pace, leading to a dramatic end in a supernova explosion. But what happens after a star dies? Well, the cycle doesn't end there. The death of a star, particularly a large one, can lead to the birth of new stars. When a star dies in a supernova, it scatters its outer layers into space, creating a new nebula. This nebula, full of the elements forged in the heart of the star, can then collapse to form new stars and planets. So every star, every planet, every single atom in your body has been part of this cosmic life cycle. Stars are more than just distant lights in the night sky. They are the forges of the universe, creating the elements that make up everything around us. Every star in our night sky, including our sun, has its origins in these stellar nurseries. The birth of stars is a tale of cosmic recycling, a testament to the ever-changing, ever-evolving universe we live in. But stars weren't the only celestial bodies being formed. Planets like our Earth were also taking shape. In the vast cosmic nursery, newborn stars were not alone. Around them, swirling disks of dust and gas, known as protoplanetary disks, were beginning to take form. These disks, rich in materials left over from the birth of the star, were the building blocks of planets. Think of protoplanetary disks as the cosmic potter's wheel, spinning around young stars. The dust within these disks starts to stick together, forming tiny clumps. Over time, these clumps collide and merge, growing larger and larger. They become planetesimals, the seeds of planets. As these planetesimals continue to grow, their gravity becomes stronger. They start to attract more and more material from the disk, growing into protoplanets. Over millions of years, these protoplanets continue to evolve, eventually becoming fully formed planets. The process isn't always smooth. Sometimes protoplanets collide, resulting in catastrophic events that can shatter them into pieces. But this isn't the end. The remnants of these collisions can come together again, forming new planets. This violent and chaotic process is thought to be how our own moon was formed. Now let's zoom out a bit and look at the bigger picture. Each star, with its family of planets, forms a solar system. But how did our solar system form? Well, it's thought that around 4.5 billion years ago, a cloud of gas and dust in our Milky Way galaxy collapsed under its own gravity. This collapse triggered the formation of our sun, and the leftover material formed the protoplanetary disk that eventually gave birth to the planets, including our Earth. In the grand scheme of the cosmos, our solar system is but one of billions in our galaxy alone, each one a testament to the incredible processes that turn cosmic dust into worlds. From the remnants of these star-forming regions, planets in our solar system were born. The formation of our solar system is a tale of chaos and order, destruction and creation. In the grand cosmic dance, planets, moons, asteroids, and comets pirouette around a radiant star we call the Sun. This is our cosmic home, the solar system. Our solar system is a bustling neighborhood, home to 8 unique planets. Closest to the Sun, Mercury, a small rocky world, races around in just 88 Earth days. Next, Venus, our sister planet, shrouded in a thick, toxic atmosphere. Then comes our home Earth, the blue jewel of the solar system, teeming with life and beauty. Mars, the red planet, a world of deserts and valleys and the focus of space exploration. Beyond Mars, we find the asteroid belt, a ring of cosmic rubble, leftovers from the solar system's formation. Then come the gas giants. Jupiter, with its many moons and iconic red spot, a storm larger than Earth itself. Saturn, the jewel of the solar system with its magnificent rings. Further out, Uranus and Neptune, the ice giants, mysterious and distant. But our solar system doesn't end there. Far beyond Neptune, the Kuiper belt, a second asteroid belt, is home to Pluto and other dwarf planets. Our solar system is but one of hundreds of billions in the Milky Way galaxy. It's a cosmic city, with our sun and planets residing in one of its spiral arms. We're located about 2/3 of the way out from the center, in the suburbs of the galaxy. Our cosmic home is a testament to the balance of chaos and order. Out of the cosmic chaos, planets formed, life emerged, and here we are contemplating our place in the cosmos. And so from the chaos of the cosmos, our solar system emerged. Our universe is a cosmic tapestry, woven from the threads of matter, energy, time, and space. From the fiery birth of the universe in the Big Bang to the formation of galaxies, we've journeyed through cosmic history. We've witnessed the birth of stars, their fiery hearts forging the elements that make up our world and ourselves. We've seen how planets and solar systems form from the cosmic dust, coalescing into celestial bodies under the force of gravity. And here we are on our cosmic home, the Earth, a product of this grand cosmic ballet. We are the children of stars, made from the same stuff as galaxies far away. This is our story, the story of origins, the story of a universe that went from chaos to cosmos, from a singularity to the sprawling, star-filled expanse we see today. So the next time you gaze up at the night sky, remember, you're not just looking at stars, you're looking at the origins of everything.